Electronic brakeforce distribution or electronic brakeforce limitation is an automobile brake technology that automatically varies the amount of force applied to each of a vehicle's wheels, based on road conditions, speed, loading, etc. Always coupled with anti-lock braking systems, EBD can apply more or less braking pressure to each wheel in order to maximize stopping power whilst maintaining vehicular control. Typically, the front end carries the most weight and EBD distributes less braking pressure to the rear brakes so the rear brakes do not lock up and cause a skid. In some systems, EBD distributes more braking pressure at the rear brakes during initial brake application before the effects of weight transfer become apparent. How ABS works: under heavy braking, vehicle wheels may lock up due to excessiveness of wheel torques over tire road friction forces available, caused by too much hydraulic line pressure. The anti-lock braking system monitors wheel speeds and releases pressure on individual wheel brake lines, rapidly pulsing individual brakes to prevent lockup. During heavy braking, preventing wheel lockup helps the driver maintain steering control. Modern ABS has an individual brake line for each of the four wheels, enabling different braking pressure on different road surfaces. For example, less braking pressure is needed to lock a wheel on ice than a wheel which is on bare asphalt. If the left wheels are on asphalt and the right wheels are on ice, during an emergency stop, ABS detects the right wheels about to lock and reduces braking force on the right wheels, helping to avoid lockup and loss of vehicle control. How EBD works, as per the technical paper published by Bushman al. The job of the EBD as a subsystem of the ABS system is to control the effective adhesion utilization by the rear wheels. The pressure of the rear wheels are approximated to the ideal brake force distribution in a partial braking operation. To do so, the conventional brake design is modified in the direction of rear axle overbraking, and the components of the ABS are used. EBD reduces the strain on the hydraulic brake force proportioning valve in the vehicle. EBD optimizes the brake design with regard to adhesion utilization, driving stability, wear, temperature stress, and pedal force. EBD may work in conjunction with ABS and electronic stability control to minimize yaw accelerations during turns. ESC compares the steering wheel angle to vehicle turning rate using a yaw rate sensor. Yaw is the vehicle's rotation around its vertical center of gravity. If the yaw sensor detects more or less yaw than the steering wheel angle should create, the car is understeering or oversteering and ESC activates one of the front or rear brakes to rotate the car back onto its intended course. For example, if a car is making a left turn and begins to understeer, ESC activates the left rear brake, which will help turn the car left. The sensors are so sensitive, and the actuation is so quick that the system may correct direction before the driver reacts. ABS helps prevent wheel lockup and EBD helps apply appropriate brake force to make ESC work effectively and easily. See also, brake assist, cornering brake control, electronic stability control, automobile safety. References